Hi there, my name is Doug Rees. I'm going to be talking to you today about .NET assembly versioning. So just a quick overview of some of the issues that we face when we're working with assemblies in .NET, and this can be .NET 1 or .NET 2, doesn't really make any difference. We've got two types of assemblies to worry about. We have weakly named assemblies. With weakly named assemblies, the version number is never checked, so the version number is not important to us. Weakly named assemblies is something we'll work with when we're in our development phase. Strongly named assemblies is when we're going to ship it out to our customer, and at that point the version number does become important. The version number will be checked. Client applications generally will only load against the version they were compiled against unless we redirect them manually. And we're going to see how to work with both of these type of assemblies in the demonstrations. So let's start a demonstration by taking a look at a very simple little library application. This library application is really just a straightforward class library. I'm using Visual Studio 2005, but the code would be exactly the same in 2003. So all we've got is a C# class library with one class and one method. Okay, so we've got a namespace called library and a class called simple class, a method called getData, and it just returns some information. I'm just going to reset this string now to its initial state. At the moment, because this is going to be a weakly named assembly, if we look at the version number in the assembly info file, you'll see that we've got it set to sort of the default version, which is 1.0. The asterisk means that the two final numbers, the build number and the revision number, are going to auto-generate, as we'll soon see. So the idea is we're going to compile this guy. We're going to go to the client application. We're going to load him up. And he's going to have a reference to that class library. At the moment, that class library is not strongly named. You can see the version number here that was generated when we did the compilation. The 2533 is the number of days since January 1st, 2000, and then the 19437 is the seconds since midnight, the day that you're building this. So all we have inside here is a very, very simple test harness. It's going to go and create the object in the class library. It's going to call the getData method, and it's going to wait for us to press any key. So we're just going to compile him up as well, just to make sure he works. Just double click some data from the class library, press any key to exit, so therefore it's worked. Okay, so now what we're going to do is create a copy of these files, and I'm going to move them into sort of a test area, paste them in here. Obviously with .NET deployment, because you can just deploy the DLL into the same folder as executable, the system just works quite happily. We'll also create a backup of these two files. And what we're now going to do is we're going to change the actual class library DLL. So we're going to go in here, we're going to modify, add the word modified into here. I'm also then going to change, well, actually I'm going to let it auto-generate a new version number for me. So we're just going to recompile that now. We're going to grab the actual DLL and replace it inside the test area. As you can see, immediately the client app is happily using the new version number without any dramas at all. Let's see what this version number is. Okay, so this is 19486, and the one that's in the backup folder, 19437. So totally different version numbers, but both are working quite happily. Of course, this guy is using him because these are effectively private assemblies, therefore they will run in the folder that they are located in. Now this is fine for development, however when you want to ship it out to your customers, it's no longer appropriate to use weakly named assemblies because there is no security checking in place on weakly named assemblies. So what we need to do now is we need to strong name our assembly. This has a few benefits, as we'll soon see, but the steps for actually strong naming is to create yourself a key pair using strongname.exe, to then assign the key using the attribute, the assembly key file attribute in the class library itself. we will manually assign a version number instead of letting it auto-generate a version number. We're going to then compile the class library in Visual Studio, and then we're going to recompile the client application once against that strong named assembly. So let's have a look now at just changing it, so we're going to use a strongly named client library. Well, the first thing we're going to need is we're going to need a strong name key. So what I'm going to do is generate myself from the .NET command prompt, strongname.exe is the tool that we're going to use. -k is the switch for saying generate us a new key. I'm going to call it mykey.snk. And you can see that it's now written a key pair to the folder where this library code actually exists. You can see the key inside here. Yes, in Visual Studio 2005 there are other ways of doing this, but this is the one that works for both 2003 and 2005. We now need to change the version number to something explicit ourselves, which we're going to do by setting it to a 0. And now we need to add in the assembly key file attribute, pointing it to mykey.snk. The reason that we need the two sort of dot slashes is because when we do the actual compilation, we're actually compiling it from the object folder inside the debug folder. So basically, the compilation occurs here. It has to step one level up to the object folder, then it has to step up again to the folder that contains the actual SNK file, because that's where I've chosen to store it. So we're now going to recompile this. Although, actually, sorry, that's one thing I forgot. I just wanted to change this to the word strong, just so that we can see that this is now a strongly named assembly. And we're going to rebuild this one. We've got to go back to the client application now, because the client application must be rebuilt once so that it knows that it's strongly named. And at the moment you can see that it thinks it's false. If I actually rebuild the application, it will check and then spot the fact that this is now a strongly named assembly, and it's got the version number that we're expecting, and so forth. So now our class library is going to be using the strongly named assembly. Let's just check that that's working. And there we go, class library strong. So it is happily using the strongly named assembly. We're going to copy those guys and replace our original pair that we had. Okay, so it's all working. The other way we can tell that this is a strongly named assembly is to use ILDASM. I'm just going to load up from the .NET command prompt ILDASM, ILDisassembler, and we're going to go and find the actual, it doesn't really matter where we're actually looking for this. If we look at the library itself and then we look at the manifest, what we'll see is that inside our manifest for our assembly is our public key, which has been embedded by the attribute. We also see our version number that we've hard-coded in here. If we use ILDASM to open up the executable, what you'll see is that the executable in the manifest now references our library assembly, and it knows our public key token and it knows our version number. And these two values are always going to be tested by the .NET framework when we actually load up our client application. It's going to look for those information.